All right, ladies and gentlemen, welcome to the last section of Algebra 2A, 6.3, talking about special right triangles and some of the applications. So, special right triangles, it comes back. You have seen it in geometry, I promise, especially if you had me. I know I talked about it. So, special right triangles, and then angle of elevation, angle of depression, that also makes a reappearance. So, let's get right into it here. We have a 45, 45, 90 triangle. That means it looks like this. 45, 90, that makes that 45 as well. So that means that if this is x, this is also x, and then to figure out my hypotenuse, it's going to be just x square root of 2. And that just absolutely stems from just using Pythagorean theorem. So if I had x squared plus x squared, that's going to equal c squared if I'm trying to figure out my hypotenuse. Well, that's 2x squared equals c squared. So if I square root both sides, so that's going to give me square root of 2, square root of x squared equals c. Well, the square root of x squared is just x. So that's where it comes from. It's just x square root of 2. So whatever my side length is, multiply it by square root of 2, and that's going to give me my hypotenuse. So if I take a look, I could use SOHCAHTOA if I wanted to. Otherwise, I can use the pattern. So if this is 4, that makes this 4 as well. That makes this 4 square root of 2. Now, I know number 2 got cut off a little bit, but if it's 5 square root of 2, that makes this 5 square root of 2. Now look what happens. So to get my hypotenuse, I have to multiply by square root of 2. So I take 5 square root of 2 times square root of 2. So square root of 2 times square root of 2 is the square root of 4, which is also known as 2, so that my hypotenuse is going to be 10. That's what I do. So all I'm doing is, if I know a short side, multiply it by, or it's the same on the other side, multiply by square root of 2 to get my answer. To work backwards, nope, not there yet. Let's talk about 30, 60, 90. I'll come back to it. So if I've got a triangle, this is 30, that's 90, that makes that 60. All right, and what happens is this. If this is 2x, that means my short side is half of that. My middle side is going to be short times the square root of 3. And again, it stems completely from Pythagorean theorem. You know, if you've got a triangle where this is 1 and this is 2, where my hypotenuse is double one of the sides, you know, if you work out Pythagorean theorem, this becomes square root of 3. So that becomes my pattern. All right, so 30, 60, 90. I take the sides across from that, short side, mid, hypotenuse. Now, kind of unwritten rule in geometry that I really, really hope makes sense, and that is that small angle across from small side, middle angle across from middle side, big angle across from big side. So for a 30, 60, 90, this is the short side, middle side, long side. So if I'm working here, my long side is 10, okay? That means my short side is half of that. That means my middle side is going to be 5 square root of 3. I don't know how this one got cut off. Try it and see what you get. And if you got a question, come talk to me about it. So if I've got 45, 45, 90 triangle here, 30, 60, 90 triangle here, start thinking about how those things go together. Find the exact value of sine 45 with no decimals. So sine of 45 means I'm dealing with this angle right here. That's opposite over, opposite over x square root of 2, okay, which I cannot have, so I'm going to multiply by square root of 2 over square root of 2. We call that rationalizing the denominator. Cannot have a square root in the denominator. So that becomes x square root of 2 on top. On the bottom, it becomes 2x. The x's cancel out. So it becomes square root of 2 over 2. There's my answer. All right, for tangent of 45, if you look, tangent of 45, that's going to be just x over x. That's just going to be 1. Remember, tangent is going to be opposite over adjacent, so it's going to be just 1. So now, sine of 60, we're jumping down here. 60 is going to be this angle right here. Sine of 60 means I want to take opposite over hypotenuse. Okay, opposite over hypotenuse. So I want to take x square root of 3 over 2x. Okay, so when I do that, x squared root of 3 and x, the x's cancel out, so I'm left with square root of 3 over 2. For a tangent of 30, 30 is now this angle. This is 30. So a tangent of 30, I want opposite over adjacent. So I'm going to want x over x squared root of 3. So now the x's cancel out, so I'm left with 1 over square root of 3. But I can't leave it like that. I can't leave a square root in the denominator. So I multiply both the top and bottom. So that becomes square root of 3 over 3. That becomes my answer. So angle of elevation is how far I'm looking up at something. Angle of depression means what angle am I looking down at something. So I want to look at this and go, how am I looking? So angle of elevation is looking up, angle of depression looking down. A lot of kids mistake this. This is not the angle of depression. A lot of kids think it is. I don't know why. That is not the angle of depression. So put a mark around that and say that is not going to do it, and don't do that on your homework or your quizzes. So if a tree casts a shadow 25 foot long, shadow is 25 feet, angle of elevation is 64, figure out the height of the tree. So a little trig here, so that's opposite, that's adjacent. So I want tangent of 64 is equal to x over 25. So tangent of 64, throw that in a calculator. Don't break your brain trying to figure out what that is. So tangent 64 times 25. So that means that this thing is going to be 51.25, approximately, 6 if you want to be technical. So that means this one's going to be 51.26 feet, rounded, 2 decimal places. So, but set up, draw a pig kind of represents your information. So when landing, a jet will average a 3-degree angle of descent. What is the altitude to the nearest foot of a jet on final descent as it passes over an airport beacon 6 miles from the start of the runway? So, this is 6 miles. Okay, so the jet has got a 3-degree angle of descent. So these are parallel, so that makes this 3 degrees as well. So I'm trying to figure out that. So I want tangent of 3 equals x over 6 times 6. All right, so x is going to equal. Now it's a decimal, but don't leave it like that. What did the problem want it in? The problem wanted it in feet. So the problem wanted it nearest foot. So this is in miles. So I just want to take my answer and multiply it times 5,280. So that gives me 1660.28. Multiply by 5,280 because that's how many feet are in a mile. So 1660 feet. So suppose a tree casts a 50 feet in height, casts a shadow that is 60 feet. What is the angle of elevation? So again, opposite, adjacent. I want tangent, but in this case, I want to use tangent inverse. So my angle theta is going to be equal to tangent inverse of 50 over 60. So tangent inverse, 50 divided by 60, is going to be 39.81. So that's going to be my angle of measure. Okay, so play around with this. I know it's a blast from the past, but I think you can do it. Make sure you come talk to me with questions.